Hello and welcome to Chapter 2, Section 6. So this time we're talking about ratios and proportions. So last week we talked all about different equations that we can solve and how to solve them, whether they're one step, two step, five steps, whether they have absolute value, and the variables on both sides. So we talked about all those. And now we're going to work on just understanding what ratios and proportions look like and how we can solve those things when we see them. So we'll talk about ratios and proportions. We'll look at means, some extremes. We'll look at some different rates and some scales as we work through these examples. So here is our first one for today. We want to determine whether the ratios are equivalent. So a ratio given by a fraction, 7 over 8, and the fraction 49 over 56. We want to look at those and think about, are they equivalent? Are they the same? And we can justify our answer. So first, to look at these, we want to know some way to compare these meaningfully, okay? And the way we can do that is by making each one in simplest form. So if we take 7/8 and we want to make it as simple as possible, there's no factor that 7 and 8 both have that we could divide by other than 1. So sure, we could divide them both by 1, but we know anything divided by 1 is just itself. So 7 over 1 is just 7. 8 over 1 is just 8. So 7/8 is the simplest form it can be, so we just leave it as is. Now we want to move over to the second ratio we're given and simplify it as best we can. So let's do that. So if we have 49 over 56, and we divide it by the greatest factor they have in common. So if we divide 49 by 7, we know 49 divided by 7 is 7. And we can double check that because 7 times 7 is 49. So that works. So we divide the same number. We have to use the same number that we did in the numerator for the denominator. So we divide 56 by 7 and we get 8. We can check that because 8 times 7 is 56. So if we divide the numerator and denominator by 7, we know 49 over 56 is the same thing as 7 over 8. Since that is the case, we can say, looking back at our question, are they equivalent ratios? And the way that we can answer that question is by understanding, is 49 over 56 another way to say 7 over 8? And we just said that these two things are equal. This is just times 7 to the top and the bottom. So 49 over 56 is the same as 7 over 8. So are they equivalent ratios? Absolutely. So to answer the question, yes, they are equivalent ratios. When expressed in simplest form, the ratios are indeed equivalent. And we see that with the 7/8 on the left and the 7/8 on the right. These are equivalent ratios. 7/8 and 49 over 56 are exactly the same thing. And you could type those into a calculator and see that you get the exact same decimal for both of those. So they are indeed equivalent ratios. 1b. Similar process. We want to determine whether these two fractions given are equivalent ratios. So we've got 5 over 6 and 40 over 49. We want to know if these two things are the same. So what is 5 over 6? Well, 5 over 6 can't be simplified. That's the simplest that would be. But if I wanted to try to make 5 over 6 equal to 40 over 49, one way I could do that is I know that 5 times what number will get me to 40? Well, 5 times 8 will get me to 40. So if I multiply the top and the bottom both by 8, I'm really just multiplying by 1. 8 over 8 is 1, but we want to try to rewrite this and see if we can get this 40 over 49 to show that they're equal. So 5 times 8 I know will give me 40, which is the numerator we see here. So that's okay. We look like we might be able to get there. So times 8 is the only way we could get this 40 in the numerator here. But we need a 49 in the denominator. So 6 times the same number, 6 times 8, has to be 49 for these to be equivalent ratios. Otherwise, there's no way these could work. So let's check that. So 8 times 6. We know 8 times 6 is 48. And 40 over 48, although it's close, is not the same as 40 over 49. So to look at this question, are these two the same? Are they equivalent ratios? We know that they are not. They can't be the same. There's no way these two could ever be the same. They're different, and you could double check that. If you plugged in these as decimals into your calculator, you would see that they're different. So for this one, they are absolutely not equivalent. So here's a rule for this section we want to quickly talk about. This is the means extremes proportion property of proportion. And we know in a proportion, the product of the extremes is equal to the product of the means. In other words, if we're given two fractions, a over b, just two numbers, equal to c over d, two other numbers, and b and d are not equal to 0, so the numerators aren't 0 because you can't divide by 0, then we can just take their cross products and say they're equal. So a times d equals b times c. So an example, if you had 2 over 4 equal to 1/2, 2 times 2, this cross product, 2 times 2 would be equal to 4 times 1. And you can check that. 2 times 2 is 4, and 4 times 1 is also 4. So a cross product will always help you to solve your proportions, get rid of your fractions, like you see here, and then solve and get a number that you can easily work with. So we'll use this rule to help us solve these proportions, and we see some examples coming up. So here's 2a. We can use a cross product to look at, are these two ratios a proportion? In other words, are they equal? So this word, when they say here, does it form a proportion? What we're really asking is, are they equal? Are they the same? That's what this means. When they say, does it form a proportion? We're asking, are they equal? Okay? So to know if these two are equal, we'll want to take the cross product of these two things. So 0.25 times 2, 0.6 times 1.25. If we do that, we can rewrite it as a product on the left and a product on the right of our equation. We'll see if it is indeed equal, and if it is, we know that they would be a proportion. So we take what we're given, we'll multiply across. So notice the arrows. From the top left, we go down across, we multiply. From the bottom left, we go up and across, we multiply. And we'll see if those two products are equal. So 0.25 times 2, we multiplied across, we carried these numbers, there they are. We multiplied across, we set them equal, we get these two numbers. Those are going to be our cross products. Now we'll see if the decimals are the same. So 0.25 times 2, I know is 0.5. You can check that. And 0.6 times 1.25 is 0.75. Clearly, when we're comparing, are these two equal, we can see that they are not. They are different. So they are not equal, hence a no equal sign. And the red X reminds us that they are not the same. Since they are not the same, to answer our question, does it form a proportion? In other words, is it equal? We say, no, it's not equal. No, it does not form a proportion. And that is our answer for 2A. We did the cross product, we found the decimal, and we said no, they're not equal, so the ratios do not form a proportion. Okay, here's another one. So 2B asks us to use these cross products to determine whether they form a proportion. So by the same process, we will take what we're given, we'll multiply across and across. We'll set those products equal to each other and see what we get. So here's our original proportion. If I multiply across here, I should get 2 times 20, which is 40. And I'll set that equal to my other cross product, 2.5 times 16. 2.5 times 16. Okay, so let's do this. 6 times 5 is 30. Bring up our 3. 1 times 5 is 5, plus 3 is 8. 2 times 6 is 12. And 2 times 1 is 2, plus 1 is 3. So we get 0, 0, 4. And we have 1 decimal place here. So 16 times 2.5 should be 40. So 40 equals 40 again. So we see this cross product. The first one was 2 times 20. That gave us 40 on the left. The second one was 2.5 times 16, which we just said here is also 40. So 40 equals 40. Does it form a proportion? In other words, is it equal? And we see, in this case, are they equal? Absolutely. 40 equals 40. These cross products are the same. In other words, the pair of ratios do form a proportion. We see their cross products check out. They equal. So to answer this question, we see yes, the ratios form a proportion. So you should be able to do a problem like that with just one step. Multiply across. Check to see, are they the same or are they different? So 2C, you want to use the cross products to determine whether they form a proportion, just like we've already done. So we'll take our pen here and we'll multiply across and see what we get, and across again and see what we get. So if we take our first proportion, 0.5 times 1.17, so 1.17 times 0.5. So we'll get nothing but zeros here. Bring down a 0. 7 times 5 is 35. 1 times 5 here, plus 3 is 8. And 1 times 5 is 5. Okay. Now we'll add this across. And we have 4 places on decimals, so we'll go over 1, 2, 3, 4. So to answer that, 1.17 times 0.5 is 0.585. So this is what we get with the first proportion. So 0.585. All we have to do there is multiply. Now we'll do the other one. So 1.3 times 0.45, what do we get? So 1.3 times 0.45. And we'll fill in the 0 here. Okay. So 5 times 0 is 0. 5 times 3 is 15. Bring over the 1. 1 times 5 is 5, plus 1 is 6. So we get 650 for that. Then we'll bring down a 0. 4 times 0 is 0. 4 times 3 is 12. And carry the 1 over. 4 times 1 is 4, plus 1 is 5. So we'll get 0, 5, 8, and 5. And we have 4 decimal places again. So there goes our decimal. And notice, hey, we have the exact same decimal here. This is also 0.585. We generated the same decimal with both of these cross products. So to answer the question, does it form a proportion? We can say yes, it does. And we know our evidence here to suggest that is that the cross products are equal. So the ratios do form a proportion. All we have to do is multiply across, check to see if they're the same. If they are, then we get that example there. So for 2C, yes, they form a proportion because they're equal. So this example 2 asks us to use these cross products, determine whether the pair of ratios form a proportion. So are they equal? And this one will be a little bit easier since we don't have decimals. So we'll take 5 and multiply by 15. That's our first one. So on the left side, what is 5 times 15? 5 times 15. Well, 5 times 5 is 25. And 5 times 1 is 5, plus 2 is 7. So 5 times 15 is 75. So we have that. On the left, we'll do 6 times 12. 6 times 12 is 72. And if you want to double check that, 6 times 2 is 12. And 6 times 1 is 6, plus 1 is 7. So there you see, 72. So does 75 equal 72? Well, no, we see that those numbers are definitely not the same. So when we're looking at these two things, they're not equal. In other words, they don't form a proportion. When we're answering that question, they're not equal. They do not form a proportion. So B, we know, is our answer here. Those cross products are not the same. The whole point of this is seeing that the fractions are different. So since the fractions are different, they don't form a proportion, and we know that that's our answer here. Okay, so the third type of example for today asks us to solve a proportion. So given a setup, they tell us what's equal to what. We have two fractions here. And they give us a variable, so one of the numbers is missing. We can solve for it by using the cross products just like we were. So we'll do n times 8. That'll give us a value on the left. And we'll do 12 times 3. That'll give us a value on the right. And we'll set them equal to each other. So 8n equals 36. The whole point of these equations is to solve for your variable. So our variable in this case is n. So we need to get n by itself. How can we do that? Well, we see we have 8 times n right here. We want to get rid of the 8. And the 8 is tied by multiplication. So to get rid of the 8, we have to do the opposite of multiplication, which is division. So we divide both sides by 8. Here, 8 over 8 is 1, so that goes away. We just get n on the left. And on the right, we get 36 over 8, which is 4 and 1/2. So let's double check that those steps are correct. So take your original. You take the cross product like we did. You get this here, 8n equals 36 like we found. And now to get n by itself, you need to get rid of the 8. You do that by dividing here since these are tied by multiplication. 8n over 8 What does that equal? The 8's cancel out like we saw on the left. On the right, we'll get 36 over 8, which doesn't come out to a whole number. 8 times 4 is 32. And a little bit more than that is going to give us 1/2. So 4 over 8 is 1/2. So we should get, for this one, n should equal 4.5, or 4 and 1/2, if we did that right. So you can write it as a decimal or as a mixed number like we did before. So 4.5 or 4 and 1/2 works for this one. Remember, all you have to do here is take the cross product. We multiply across, we get a value, multiply across, we get a value, and then we do whatever it takes to get our variable by itself. Imagine a box around your variable. To get that alone, you need to undo whatever's around it, whether that's subtracting, dividing, whatever it is. You always need your variable alone, and you do the right operation to get there. So now that we've seen some examples, we should be able to do these, no problem. For today, we will finish the rest of this section as we move forward in later days. But for today, we should be fine with these examples.